Okay, let's start. Let's start today's session. So last week we have started quadratic functions and equations. Quadratic functions and equation. Today we need to go further. About quadratic function, further quadratic functions, and then move to quadratic equation. Okay. Now, see this one all. You identified ax squared plus bx plus c is a quadratic function. Then we say a, b, c real values and a not equal to 0. A not equal to 0. Here this is quadratic function. Okay, quadratic function. Then a greater than 0, minimum shape, a less than 0, maximum shape, parabolic shape. It has symmetrical axis, it has vertex. Then here this vertex we say minus b divided by 2a minus delta divided by 4a. Minus delta divided by 4a. Here this is minimum or maximum value. Minimum or maximum value. And further, here x-axis. So here the minimum has 3 possibilities. Maximum has 3 possibilities. Here maximum has 3 possibilities. For this case, delta greater than 0, delta less than 0. Here delta equals 0. Here delta greater than 0. Here delta less than 0. Delta equals 0. Delta greater than 0. 3 different cases. Okay, that is quadratic. Okay, then further, here quadratic function ax power equal, this is leading term, and c we call constant term. Most of the properties depend with the leading term. So here quadratic function has 3 different forms. One is factor form, y equal a times x minus alpha, x minus beta. Second one, y equal a x plus p square plus q type vertex form. Then general form, y equal ax squared plus bx plus c. Then by completing square method, we convert into vertex form. By completing square method, we convert general form into vertex form. That is the thing. Okay, that is the thing. Okay, then those are the things about quadratic functions. Then sign of the function. Finally, the sign of the function depends it a greater than 0 and delta less than 0, function positive, a greater than 0, delta equals 0, function non-negative, then a less than 0, delta less than 0, function negative, a less than 0 and delta equals 0, function non-positive. Here the thing about sign of the function. Here different forms. Here these are graphs. Here a small revision part. revision about quadratic functions. Quadratic functions. Okay. First of all, you better to write it first. Kalian kalla tiyan kamay apa matakin na product yan just note tab daga. Okay. Now you put special subtopic. Special subtopic right now. Nature of the roots. Nature of the roots. Nature of the roots of a quadratic function. Nature of the roots of a quadratic function. Quadratic equation. Of a quadratic equation. Of a quadratic equation by the corresponding graph. By the corresponding graph. Okay. Now you consider the graph. Here minimum shape graph, we have three possibilities. We have three possibilities. Here x-axis, here we say let y equal ax squared plus bx plus c. Then corresponding equation we say ax squared plus bx plus c equals 0. We call quadratic equation. Here quadratic function. Now if that cut at two different points, we say roots real and distinct. Roots real and distinct. We have two different points. That's why we say distinct. Here for this case, we say roots real and coincident. Real and coincident. And this is we say root not real. Not real. Okay. Then here x-axis, we have three possibilities again. So here we say roots real and distinct. So we have here two intersection point, but here we have only one touching point. Then roots real and coincident. Coincident means same. Here roots are not real. Roots are not real. Okay. Not real, but they have solutions. Okay, but they have solutions. So as an example, consider x square minus 2x minus 3, 0. First example, here we have factors x, x3, 1, minus, plus 0. X equal minus 1, x equal plus 3. Here first case, it cut. Then second one, x square minus 4x plus 4, 0. Here we have x minus 2 square, 0. Then solutions x equal 2 and 2. Real and coincident, here real and distinct. Two separate. Third one, x squared plus x plus 1, 0. Then here x equal minus 1 plus or minus b square minus 4ac root divided by 2a. Then minus 1 plus or minus root 3 divided by 2. Here within square root negative value. Then roots not real. Here these two roots are real. Here real and distinct, real and coincident. Here not real. Okay. Here roots not real. Here roots are real. Real. Then here real and coincident, distinct, and here coincident. These are examples. Okay. Then root mean intersection point, x intercept point. Okay, root mean x interceptions. Then by equation, we identify x-intercepts. We analyze x-intercept. That is the thing. Okay, just write down. Let a quadratic function, y equal ax squared plus bx plus c. Y equal ax squared plus bx plus c. The graph has two different forms. The graph has two different forms. Within bracket, opens up, comma, opens down, opens up, comma, opens down. Okay. Then next line, for each case, there are three different positions. With respect to the x-axis. With respect to the x-axis. With respect to the x-axis. First case, when the function cut the x-axis, when the function cut the x-axis, the corresponding equation has two real solutions. They are distinct. Next star mark. When the function touch the x-axis, the corresponding equation has two real solutions. They are coincident. Okay. Third case, when the function is not contact with the x-axis, then the corresponding equation has no real solutions. Okay. 4th, but here there can be imaginary solutions or complex solutions. Here there can be imaginary solutions or complex solutions. Imaginary solutions or complex solutions. Okay. Now just write these things. Take a little time. Okay. Now see this important pattern. Consider y equal x graph. Here x-axis, y-axis, then y equal x square graph. Here x-axis, y-axis, parabolic shape, it touch the x-axis. Then y equal x cube graph, x cube graph. Then corresponding graph, here x-axis, y-axis, it goes like this and touch goes like this. Then here corresponding equation x equals 0. We have only one solution. Here corresponding equation x square equals 0. We have two solutions. X equals 0 and 0. X equals 0 and 0. Then y equal x cube. X cube equals 0 corresponding equation. We have three solutions. X equals 0, 0 and 0. Okay. Then you identify when it touch like this, we have two equal solutions. When it touch like this, then you remember we have three usual solutions. Okay, three usual solutions. Now consider y equal x minus 1, x minus 2. Here x-axis, it cut at 2.1 and 2. Then minimum shape graph, no? Minimum shape graph. Here y-axis, corresponding intercept will be 2. Then y equal x minus 1, x minus 2, x minus 1, x minus 2, x minus 3. Then here leading term positive. Here x-axis, it cut at 1, 2 and 3. 1, 2, 3. It goes like this. Inequalities we have done. In that case, we have done this graph. When x0, y value minus 3. Here x0, y value minus 1 into minus 2 plus 2. Here x value 0, y value minus 1 into minus 2 into minus 3 minus 6. Then y equal x minus 1, x minus 2, x minus 3, x minus 4. Here x-axis, leading term positive, then it goes like this. Then here intercept 1, 2, 3, 4. Here 1, 2, 3, 4. Then y cut, substitute x0, 1 into 2 into 3, 6 into 4, 24. That's how we sketch now. That's how we sketch. Then when we have factors, then we better to sketch like that way. By first get interception point, then sketch. No, that is the procedure. Okay. Then thereafter, you consider y equal x minus 1 square times x minus 2. Here three different interceptions. Here we have two different interceptions. Now here we have two different interception, but one is coincident. No, repeating. No, repeating means coincident. It touch at 1. Now when you sketch this, get 0 value 1, get 0 value 2. Then leading term positive, you start sketching like this. Then turn. Then at this point you touch it and again turn. Okay. Then consider y equal x minus 1 square x minus 2. So if you have minus sign outside, you do this say. Here x-axis, here 0 values, 1 and 2 same, 1 and 2 same. Then leading term, here leading term negative, then you start this say, cut this one, we have only one factor, no? Then you cut it, then thereafter turn, then at this point you touch it, it goes like this. That's the thing. Okay, then you consider y equal x minus 1 cube, x minus 2. Here x-axis. Now here we have 3 times repeated 1. No? 3 times repeated 1. Then get 0 value 1. Here 0 value 2. Leading term positive. Start sketching like this. Then turn it. Then at this point touch it. This way you sketch the graph. Here there are small change. Yeah? Small change here. Touch. It goes like this. Okay. Here y equal x cube graph. It goes like this. No? We call increasing inflection. Here this is also inflection point. Inflection point. So if we have 2 repeated factors, you need to touch the axis with minimum or maximum. If you have 3 repeated factors, you touch with inflection. Touch with inflection. Okay. Now better to sketch them. This pattern better to sketch. Not it. මේ y equal x cube කියන එක පොඩ්ඩක් බලන්න. මේක මේ touch එක වෙන්නේ එක point එකකින්. Only one single point it touch. At this point it touch, but here you can see horizontal line. ඒ වුණාට මෙතන at one point it touch. At one point it touch. Here it has, when it has only one factor, it cut, it touch, it cut, cut, cut. Here each case it cut. Now this case it touch, cut, then repeating it touch. Then here it cut, then it touch, then it touch. Continue. Okay, now see this one all. So you consider y equal fx, y equal fx function. Fx function I told initially quadratic. Okay, but fx function can be different. That can be quadratic, that can be any polynomial type, that can be rational type, trigonometric type. Likewise, there are many solution type, many functions type. Then you consider y equal fx and y equal gx. Here we have two functions y1 and y2. So when you sketch function x-axis, y-axis, let's say these are quadratic functions. Let's see, let fx gx quadratic functions. Here opens up, let opens down case. Two different cases, opens up and opens down case. So when you sketch the graph, if it is like this and if it is like this, then here you say function fx. Then here you say function gx. Here opens up, opens down case. So here gx function cut at two x distinct point. Then you say gx equals 0, gx equals 0 has two real solutions. Two real solutions. So here function fx again cut at two distinct x point. Therefore you say because of that fx equals 0. Fx equals 0 has two real solutions. Two real solutions. Now thereafter these two graphs cut at two distinct points. These two graphs cut at two distinct points. Okay. Therefore we say fx equals gx. Fx equals gx. Here these 2 points we call fx equals gx. Balagan hundred balagan. Fx equals gx corresponding equation, then fx minus gx equals 0 or fx gx minus fx equals 0. Here fx equals gx equation mean fx minus gx equals 0 or gx minus fx equals 0. These three equations are same. Huh? So it cut two distinct points. No? Then you say has two distinct real solutions. Two distinct real solutions. You identify when two graphs cut at two distinct points, then definitely when they equate, fx equals gx equation has two distinct solutions. Two distinct solutions. And see this one, the graph like this, here fx and here gx. Then take here graph like this. When they touch, here function fx, here function gx. Here graph like this, three different cases. Here fx, here gx. Here for this case, quadratic equation has two real distinct solutions. But here it touch, no? Touch means it has only one, but same real solutions. Equal and same solutions. Here they do not cut, no? Then no real solutions. Here say no real solutions. Solutions for fx equal gx. Here for this case, two real and coincident solutions for fx equal gx. Here coincident, real and coincident. Here no real. Here for this case, two real and distinct solutions for fx equals gx. Fx equals gx. So previously we identified only about one function, no? One equation. Then next case we identify two different functions. So when we equate them, we can create another new equation. Okay, just write this one. Just write this. මේ මේක පොඩ්ඩක් ක්ලියර් කරගන්න. normally ෆන්ක්ෂන් එකක් x axis එකට උඩ හරි පල්ලේ හරි තියනවා නම් contact වෙන්නේ නැතුව ඒ ෆන්ක්ෂන් එකෙන් හැදෙන ඉක්වේෂන් එකට සොලියුෂන්ස් නැහැ. හරිද? ඒ කියන්නේ දැන් මෙන්න මේ ෆන්ක්ෂන් එක තියනවානේ. මේ ෆන්ක්ෂන් එක මේ x axis එක කට් වෙලා තියෙන ඉඳන් fx equals 0 equation එක නෙමෙයි fx equals 0 equation has real solutions. මේ ෆන්ක්ෂන් එක පොඩ්ඩක් උඩට ඉස්සලා මෙතන තිබුණ නැත්නම් කට් වෙලා අපි ඊළඟට එක්සැම්පල්ස් බලනවා. මම ඉස්සලා තියනකොට ඒක කට් වෙන්නේ නැහැ. ඒකට සොලියුෂන්ස් නැහැ එතකොට. ඊළඟට fx equals gx කියන ඉක්වේෂන් එක. ඒ කියන්නේ මෙතනින් හැදෙනවා ඉක්වේෂන් එක. ඒ මෙයා හරි කිව්වත් කමක් නැහැ. ඒතර එතනින් ගන්නකොට මේ දෙන්න කට් වෙනකොට එයාට සොලියුෂන්ස් දෙකයි. හැබැයි මේ තියෙන්නේ කේස් තුන. ඔය ෆන්ක්ෂන් එක තියෙන්න පුළුවන් possibility මම මේ කිව්වේ. ඒතර ෆන්ක්ෂන් එකක් මේ විදිහට තියෙනවා නම් මේ දෙන්නගේ two real solutions distinct. මේකේ only one real solution. හැබැයි coincident. හරිද? මේකෙදි no real solutions. No real solutions මේ කේස් එකේදී. අපි examples ඔකට බලමු. Now consider this example. Consider this example. Let y1 equal x square minus 2x plus 8. y2 equal minus x square plus 2x plus 10. Plus 10. Okay. Then complete square method, x minus 1 square, 8 minus 1 square, then x minus 1 square plus 7. Here take minus outside, x square minus 2x minus 10. Then x minus 1 square minus 10 minus 1 square. Then x minus 1 square plus 11. No? Here minus 11, expand bracket, plus 11. Then sketch them. Here x-axis, y-axis. Here x equals 1. Then here 7, leading term positive, minimum. Let's say 7 somewhere here. May scale like a may 1 turn scale like a 7 minimum shape. Then x0, y value 8. It cut at 8. Minimum shape, intercept at 8. Here graph y1. Then that do not cut the x-axis. No? Then y1 function do not cut the x-axis. Therefore, y1 equals 0. y1 equals 0 has no real solutions. No? Then y1 equals 0 means x square minus 2x plus 8. X square minus 2x plus 8 equals 0. Has no real solutions. Okay. X square minus 2x plus 8 equals 0 has no real solutions. Then here symmetrical axis 1, minimum point, maximum point 11. Here 11, take 11 here. Then its intercept, maximum intercept 10. Now it goes like this. Intercept 10. Here y2 function. Then definitely it cut x-axis. Definitely cut x-axis. y2 function cut the x-axis at two distinct points. Therefore, y1, y2 equals 0. y2 equal here minus x square plus 2x plus 10 equals 0. That has two distinct real solutions. No? Has two distinct real solutions. Okay, further, these two functions cut at two distinct points again. Two distinct points. Then y1, y2, here special, very special point. y1 and y2 cut at two distinct points. Therefore, y1 equal y2 equation has two distinct real solutions. Two distinct real solutions. Okay, let's see the equation. y1 equal y2. Then y1 mean x squared minus 2x plus 8. y2 mean minus x squared plus 2x plus 10. Take the other side. 2x square minus 4x minus 2 0. Then x square minus 2x minus 1 equals 0. Now here the equation. y1 equal y2 equate then the corresponding equation is this. එහෙනම් මෙයා ගැන discuss කරන්න පුළුවන් එකේ. y1 equal y2 equation contain two distinct real solutions. හරිද? ඒ තමයි example එක. ඒතර ඔයාලට බලන්න තියෙන single function එකක් තියෙනවා නම් ඒකේ x axis එකේ cut එක functions දෙකක් equal වෙලා හැදෙන equation එකකට ඒ දෙන්නගේ cut එක බලන්න. ඒතර මේක අපිට quadratic equation වලට වඩා හරිද quadratic වලදී අහන්න possibility එකක් තියෙනවා. ඊට පස්සේ differentiation equation එක trigonometric equation එකෙත් මේක අහන්න chance එකක් තියෙනවා graph එක. ඒතර number of intersection point number of real solutions වලට equal වෙනවා. Number of intersection points equal number of real solutions. Okay. මේක දාගන්න example එකක් විදිහට. පාට papers 10ක් තියෙන පොඩි බුක්ලට් එකක් දීලා තියෙනවා. ඒකේ හිමීට ටර්ම් ටෙස්ට් එකට කලින් කරන්න පටන් ගන්න මම ඒක ඩිස්කෂන්ස් ටික දෙනවා වෙබ්සයිට් එකේ. ඔතන ගොඩක් වටින ප්‍රශ්න තියෙනවා. සමහර තැන්වල ඔයාලා හිර වෙන්න බලන තැන් ටික highlight වෙලා තියෙන තැන් තියෙනවා. එහෙනම් පොඩි priority එකක් දෙන්න ඒක කරගෙන යන්න. ටයිමින් කරලා කරත් කමක් නැහැ, කරේ නැතත් කමක් නැහැ. ඔහොම තමයි paper structure එක. හරිද? මේ සාමාන්‍ය first term based එකක් තමයි තියෙන්නේ. අන්තිම හරිය ප්‍රශ්න වලට තියෙනවා මේ differentiation part එකකුත් ඇඩ් වෙලා ඇති අන්තිම හරිය. ඒ කියන්නේ paper 1 2 වගේ තියෙන ප්‍රශ්න දෙකක් විතර ඇති. ඒ ටික උනාට කරන්න ගන්න ඔයාලට තව term based papers 6ක් මම දෙනවා. first term based papers තව papers 6ක් දෙනවා PO 3යි applied 3යි. ඒ කියන්නේ ඕකට අමතරව දැනට අපි දෙකක් කරලා තියෙනවා. Okay, now you try this question. You try this question. Okay, you try this, Anna. Sketch y1 equal x square minus 4x plus 2, y2 equal 3x plus 1. Sketch y1 equal x square minus 4x plus 2 and y2 equal 3x plus 1 on same Cartesian plane. On same Cartesian plane. Write down. On same Cartesian plane. And discuss nature of the roots of the equations x square minus 4x plus 2 equals 0 and x square minus 7x plus 1 equals 0. And discuss nature of the roots of x square minus 4x plus 2 equals 0 and x square minus 7x plus 1 equals 0. Okay, you try it. one function is quadratic, the other function is linear. Okay, now if you have any doubt, do with me. By one function x square minus 4x plus 2, no? Then x minus 2 square plus 2 minus 2 squared, x minus 2 squared minus 2. Now sketch it. Here x-axis, y-axis, symmetrical axis 2, vertex 2 minus 2. Minimum shape, x0, y value 2, passing through 2. Here 2. y1 graph. Then y1 graph cut at 2 distinct point, the x-axis, no? Therefore, y1 equals 0. y1, the y1 function cut the x-axis at 2 distinct points. Two distinct points. Therefore, y1 equals 0. Then corresponding equation x square minus 4x plus 2 equals 0 has two real and distinct solutions. Two distinct and real solutions, corresponding equation. Then y2 equals 3x plus 1. Here 1, here intercept 1. Then definitely it cut 1 point. Then definitely line goes with constant inclination. Therefore, they kept at two distinct points. Sure, එකනම cut වෙනවා අය දෙන්නෙක්ගේ තැන් දෙකේ. y1 equal y2. y1 and y2 cut each other. Two distinct points. Two distinct points. Therefore, y1 equal y2. X square minus 4x plus 2 equal 3x plus 1. Then x squared minus 7x plus 1 equals 0 has two real and distinct solutions. Two real and distinct solutions. You sketch each graph on same plane. When sketching each graph, need to consider about scale. Need to consider about scale. Okay, you try second question. Sketch y1 equal x square minus 2x plus 6 and y2 equal minus x square plus 2x plus 9 on same OXY plane and discuss nature of the roots of first one x square minus 2x plus 6 equals 0. Second one x square minus 2x minus 9 equals 0. Third one 2x square minus 4x minus 3 equals 0. Okay, try it now. Try it. අපිට හැම ලෙසන් එකකම වගේ තියෙන්නේ හරි පොඩි තියරි පොයින්ට්ස් ගාලා ඒක හරියට ඇනලයිස් කරන්න හැටි ප්‍රැක්ටිස් කරන්න. හරියට ප්‍රැක්ටිස් කරා නම් ඕන දෙයකට ඇප්ලයි කරගන්න පුළුවන්. Okay. Now y1 x square minus 2x plus 6 x minus 1 square 6 minus 1 square x minus 1 square plus 5 y2 minus x square plus 2x plus 9 take minus outside x square minus 2x minus 9 x minus 1 square minus 9 minus 1 square then x minus 1 square plus 10. Now you sketch them. Definitely you need to practice complete square method and you need to practice sketching graph quadratic functions. We have three different forms: general form, factor form, vertex form. When sketching functions, better to convert into vertex form. Then only we can identify its vertex. Now sketch it. Here x-axis, y-axis. Both case symmetrical axis 1. Here symmetrical axis 1. That x-axis is this. Both case symmetrical axis 1. Here vertex 5. Take 5 somewhere here. Here leading term positive, then minimum shape. Intercept 6. Intercept 6. Here cut at 6. මේවා ඔයාලා ස්කෙච් කරනකොට අත හුරු කරගන්න වෙන ඇබ්නෝමල් ෂේප් අදින්න එපා. හරිද? පොලිනෝමියල් ෂේප් එක කියන්නේ පැරබොලික් ෂේප් එකම අදින්න. හරිද? අනිත් ෂේප්ස් තියෙනවා ඒකයි. Okay, then here y1, y2, here 110. 10. Leading term minus, then maximum shape. So intercept 9. Here y2. Then y2 cut two distinct points, the x-axis, no? y2 cut the x-axis two distinct points. Therefore, y2 equals 0 has two distinct real solutions. y1 that do not cut the x-axis, therefore no real solution. y1 equal y2, they cut, no? Then corresponding equation has two real solutions. y1 equals 0, x square minus 2x plus 6 equals 0, no real solutions. Where y1 do not cut x-axis. Second one, y2 equals 0. Then it discuss with minus x square plus 2x plus 9 equals 0. But given x square minus 2x minus 9, then x square minus 2x plus 9 equals 0, minus 9 equals 0, both same. Two real and distinct solutions. Two real and distinct solutions. Where y1 cut, sorry, y2 cut the x-axis. Third one, y1 equal y2. Then corresponding equation, x square minus 2x plus 6 equal minus x square plus 2x plus 9. Then 2x square minus 4x plus minus 3 equals 0. Minus 3 equals 0. They cut, no? Then has two real solutions. Two real solutions. Has two real solutions. How do they cut at two distinct points, therefore two real solutions. Completed. Okay, you try question number 3 alone. Similar type question, but very important pattern. Identify properly.
hari podi interlag ganna